Hi all, Peter from Not Just a Geek here. Earlier this summer we picked up a second-hand electric car as an investment. Details to follow in a future video. This meant we became eligible for the Octopus Intelligent Tariff and so made the switch earlier this month. Since then, it's been announced that intelligent customers can now switch to more attractive export tariffs than the Smart Export Guarantee, and so we've chosen to switch to the Octopus Fixed Outgoing Tariff. The main benefit of this is that export rates on the Intelligent Tariff have increased from 4p to 15p. With the 6-hour minimum window at night of 7.5p for import, there is a financial benefit to shifting as much of our consumption to the 6-hour window. For us, this includes fully charging home storage batteries, heating our hot water tank, washing and drying clothes, and charging the car. To further capitalise on this change, we want to run as much of the house as possible off the battery and export most, if not all, of our solar generation to the grid. We've automated these behaviour changes in Home Assistant, and I'll go through the steps we've taken in this video. As you can see, it shows us how power flows throughout the home with current generation of 525 watts from solar, current house usage of 229 watts, and then power going to the grid. There's also a tiny bit going to the battery, which is technically just power that's being used for running the controller and what have you. It's not actually being used to charge the battery currently. So, with our control system, it's all handled by something called the Home Power Management Automation over here. If this was enabled, then this would automatically ensure that excess solar was being fed into the battery and it would minimise grid export. But given we're in this scenario where it pays to export to the grid, in fact it's cheaper to buy from the grid at night and sell to the grid in the day, we don't want this enabled quite right at the moment. In terms of the Octopus Intelligent Tariff, we've got a few automations that help us with stuff. One of which is the cheap charging automation, which we're going to look at now. As you can see, that one's turned on. And that's what handles our overnight charging of the battery. So it has a few triggers. One of them is the start of the period, 11:35 at night. Another is when the period ends at 5:25. The start one is called start charging, and the finish one is called end cheap charging. And these relate to the actions that happen later in the automation. So in the scenario where we have start charging, we turn off home power management, and then we set something called turn on charge batteries max power. And this will then lead to an automation that runs and charges the batteries at max power. As you can imagine, there's something similar for when we end the cheap charging period. Specifically, we turn off charging the batteries at max power. We write to a register using Modbus on the Victron inverter a value of 0, telling it to not draw or export any energy. Then we turn off anything that's kind of a high demand usage appliance within the home, and we turn home power management back on. This is the thing that automatically exports from the battery when there's a requirement for power. So let's have a quick look at how the charge batteries max power script works. Sorry, not script, automation. Sorry. Force battery charging is what the automation is called. So whenever the charge battery's max power changes to 1, this starts, and it repeats an action every 50 seconds while that is on. So as soon as this turns off, this will stop. And the action is it writes to a register using something called Modbus. Modbus is a protocol for communicating with devices, and it's a very simplified protocol that provides effectively a value that you can send and an address which takes the form of kind of a main hub and a unit. So in this case we've called it address is 37, the unit is 227, and we're saying just charge at 3 kilowatts whenever we're on max power is on. And we send this every 50 seconds because every minute that passes without a message, the inverter goes to pass-through, which is its default behaviour. So that's how the cheap charging automation works overnight. Now what we're interested in, of course, in this video is extending that. So that's great in that we're saving energy, but we have a few problems at the moment. So at the moment we've got 404 watts of solar. The house is using 221. If the house started to use more, let's say I turn on an immersion heater, suddenly we're pulling power from the grid. We don't want that to happen. We want in this scenario for the power to come from the battery. And so what we want is a scenario where we can have solar exported without having to turn off the home power management system. So let's have a look at the home power management automation to try and understand how that works. And then after we've looked at that, we'll build a new automation to export as much solar as we can during this period. So it's home power management. So as we saw on the other dashboard, this is currently disabled and it's triggered by a few things. So one is if required home power changes. So this is a calculated entity in Home Assistant, and it just works out what the current required power by the house is. So if we had the immersion heater on, it would be 3 kilowatts plus whatever else is being used. If we don't have it on, it might be a negative value. Like if we've got more solar than the house is consuming, then that will become negative. And then we've got something called the use battery script, which is the main thing we're going to be concerned about in terms of home power management. So let's have a quick look at that. I'm sorry, this is a bit of a windy journey, but it's useful for understanding the context later. So we've got the charge battery template. So this basically says if the value of required home power, which is an integer, is less than -20, take away the value of background export, then we do this. We write to a register on the Victron inverter, 0, take away required home power, take away background export. And the reason it's written like this is because when we're charging the battery, we give it a positive number. When we're discharging, we give it a negative number. So in this case, it's 0, take away, to effectively make it a positive. When we're discharging the battery, it's a similar thing. We've got a template condition that checks, this time if it's greater than -20, and then we perform a Modbus message again. This time it's required home power Modbus, which is the negative value because we're charging the battery, and this time it's given a slightly different name because it's using 2's complement. That's how we're sending a negative value using Modbus, because it doesn't support signed integers, if that's relevant to your understanding of the world. So what's interesting in both of these is they take advantage of something called this background export number, and with this we can change this value to dictate how much energy goes to the grid. So if this number matches our solar generation, then that is how much power we will export to the grid. Let's create an automation. So we're going to go to Automations, Create Automation, and we're going to start with something completely new. The trigger is going to be a state change, so this means every time this value changes, the automation will run. And and Roof Solar Power is an entity provided by Shelley, so that's effectively a CT clamp providing the power reading from the solar array. We're going to add a condition, which is that we want to make sure that there's enough solar for it to be worth doing this effort. So we'll do it only when there's at least 100 watts being generated. 100. And then we will add an action, which is call service, and it's going to be input number set value. Now, the problem that we've got is the value that we want to set is going to change. So if I knew I always wanted to set it to, let's say, 100, I can put that here. But I need to put something slightly more intelligent. I need to put a template in so we can read the data from another entity within Home Assistant. I can't remember how you do that off the top of my head. So we're going to cheat, I think. Well, actually, we'll try and remember, and if it doesn't work, we'll look up what we've done previously. So I think if we do that, then that and states sensor.required roof solar power, and we want to make that an integer, which means a number, because it will get confused if we send it a string or something, and that might be all we need to do. Let's see if that works. I'm going to call this, it's the Intelligent Octopus tariffs. We'll do Intelligent Octopus, tariff and solar export. Okay. Oh, sorry, I should have just written int there. Not quite with it. Right, let's see if that's working. So if it is, we should see this value changing. We are not seeing that value changing. So let's have a look at a previous tariff and see, previous automation and see how we've done it previously. So in Flux, we did the same thing to ensure exports at certain times of the day. So let's just copy this and then go back to our IO tariff, and I'm just going to paste all of it frankly and then go from there. So it will be that, and it's not required home power in this case, it is roof solar power. Right, let's see if this works. So save, and again we should see some changes now to background export, but we're not. Ah, no, now we are. Okay, so we must have been waiting for a change. And so as you can see, this is now set to exporting 143 watts, which is whatever the solar is currently set to. So what if we now turn home power management on? We expect two things to happen. We expect all of that power to go to the grid, and then there's going to be a deficit here, which is the power that the house needs, which we're expecting to come from the battery. So let's try that. So we turn it on, and ready, steady, go. So we are now sending 266 watts from the battery to the house. We're exporting 131 to the grid, give or take, and it appears that the automation is working. I hope you found this video interesting. If you find this kind of content with home automations useful, then please do let me know. If you have any questions about trying to do something like this yourself, I'd be happy to give you a hand, even with a different battery setup. Many of them are controllable with Modbus or MQTT or some other form of API, and I'm sure there's a solution going forwards. In the long term, I have other videos coming up which might be of interest. One is about the electric car we've purchased and why I think that's actually a wise investment, and I mean investment as in one that will make money. Other stuff that's coming up is going to be a video documenting the Victron ESS modes and how we use them for controlling our home storage battery, but also how they might be useful to others in different circumstances. I'm also planning to do some more videos about automations, specifically looking at Intelligent Octopus and battery discharge control. Something regarding a DIY mixergy tank, where the control is done through Home Assistant using a standard hot water tank, and also some automations related to the demand flexibility server, which is running again this winter. If any of these sound of interest to you, then please do subscribe, and I look forward to seeing you in a future video. Bye!